Hi, everybody, and welcome to today's Germination Retail Roundtable webinar. My name is Mark Zinkowitz, and I serve as editor for Germination, and I'm happy to be your host today. Today, and what those tests do, and how test results are reported to the customer, and what those results can be used for. Before we begin, I just would like to thank our sponsor, 2020 Seed Labs, for their support. You can check out their website at 2020seedlabs.ca or follow them on Twitter at 2020 Seed Labs. And just to let you know, this webinar is being recorded and will be posted on our website, germination.ca, following the event. I'd like to introduce our speakers today. I'm just going to My apologies. I'm going to introduce our two speakers today, Carrie and Rachel. Feel free to turn your webcams on for a moment. Carrie is Operations Manager at 2020 Seed Labs. She's been working in agriculture for over 20 years, with 15 of those years being at 2020 Seed Labs. Growing up in an ag community, Carrie always knew that she would be working in ag, and she's always loved plants and nature, as we all do in this industry. Welcome, Carrie.
Hi, Mark, and hi, everybody out there. Thank you for joining our webinar today. We've done something a little bit different. We really wanted to take you guys on a inside look in our lab and how we treat samples and how we consult with our customers about seed testing. So I hope you'll enjoy it.
Welcome, Carrie. And Rachel Malenka will be joining us as well. Rachel, feel free to turn on your webcam as well. She is the Client Success Manager at 2020. She grew up on her family's farm near Warwick, Alberta, and currently her parents are full-time grain farmers. Welcome, Rachel.
Hi, everyone. Thanks, and thanks for joining us.
Now, as Carrie was just saying, Rachel and Carrie and the staff at 2020 have recorded a little presentation for us where they take us inside their lab and show us how things are done. So I'm going to play that for you now. It's about half an hour, so settle in and enjoy. And if you have any questions for our speakers, please type these into the chat box at any time during the presentation, and we will address them after the presentation is finished playing. So again, settle in, everybody. Thanks for spending your lunch hour with us, and I will play that now.
Good afternoon, everybody, and welcome to today's webinar. My name is Carrie Matheson. I'm the Operations Manager of 2020 Seed Labs, and today we're going to take you through taking your seed to the doctor.
Woo. And I'm Rachel Malenka, and I am the Client Success Manager here at 2020 Seed Labs.
So I'm going to show Rachel what it's like to bring your seed into the lab and how you can use seed testing to get a more comprehensive idea about what sort of seed quality you have and make some good decisions for your farm. So we have two samples here of wheat that have been dropped off from two different producers in different areas of Alberta. So what we're going to do today is we're starting with the germination test. They've only requested germination on both of these samples. And so we're going to prep the sample for germination. We're going to give you a little bit of a tour through the lab, and we're going to find out what's wrong with these seeds. If anything, maybe these seeds are great. Okay, so Rachel, we're starting with germination testing. That's pretty simple. Everybody does germination. If you were going to choose between these three types of media for germinating the seed, what do you think we should use? So we've got some sand. We've got some laboratory soil, and we've got this piece of paper.
I'd probably choose the soil.
Right. So how come you would choose the soil?
Because it just replicates like what the grower will actually be planting the seed into, right?
Right, yeah, that makes the most sense. We should do soil seeds growing soil. But in the laboratory, we actually use this piece of paper.
Okay.
And I like to say that a seed is a beautiful piece of life. It really doesn't need a whole lot of things in order to start growing. In the laboratory, we just want to give the seed just the basic essentials that it needs to start its growth for the first 2 weeks of its life. That's really what we're analyzing. And so in order to do that, we want to isolate the conditions that we're going to be growing in. So we're really just looking at those kind of 3 basic things that a seed needs at the very beginning of its life.
Right.
So that's going to be moisture retention. So something like this is going to give consistent moisture.
Okay.
We also need adequate aeration so that the seed gets the air that it needs to continue and it doesn't like choke out or drown to death.
Yeah.
So that's also something that this piece of paper is going to get. And then temperature.
Right.
So all of our methods that we get here for germination testing come from another testing organization. So for example, CFIA.
Right.
So CFIA is Canadian Food Inspection Agency. They give us the protocols. We have to adhere to them as an accredited body to make sure that we're conducting the test in a certain way. Okay. So that when you send the seed here, you're going to get an accredited test, or you send it to the lab. You also get the same standard of testing.
Right. Okay.
Okay. So today we're going to test these for germination. So let's take a look at some sample number 1.
And where are these samples coming from?
So one sample is from Peace Country.
Okay.
And the second sample is from southern Alberta.
Okay.
So this is the first sample. We received this from northern Alberta. And there's not a ton of seeds in here. So if we take a look in there. Rachel, how many seeds do you think we have in there?
Like maybe 1,000, in the thousands?
Yeah, maybe there's like 1,000 seeds in there. So this was taken from, of course, a much larger seed lot.
Yeah.
In Canada, there are no maximum seed lot sizes. There's recommendations for that. But let's just say that this came from a seed lot that was around 10,000 kilograms. How many seeds do you think is in a seed lot of 10,000 kilograms?
Like in the millions for sure.
It's in the millions.
Yeah.
It's like 250 million. It's a lot. So someone has taken this sample, and I hope that they've taken it with great care, because when we're trying to obtain a representative sample from a very large seed lot of 10,000 kilograms, and it comes in with maybe 1,000 seeds, we want to make sure that every seed in here is going to represent the whole lot.
Right.
Now, in that whole 10,000 kg seed lot, how many times do you think germination should be tested in order to obtain the result you need to sell in Canada?
I'd say like once. I think that would be okay.
Right, so
Yeah.
it's just one time. So if you're going to take 250 million seeds and you're going to test it just one time, it becomes really important how you sample
Right.
a seed lot.
Yeah.
So we've got about 1,000 seeds here. We are going to select only 200 seeds for germination.
Oh wow. Okay.
Right?
Right.
So that's not many seeds. So what we want to do is, in the lab, we can't really, we're not authorized in the lab to inspect how the sampling is done outside, but we're only as good as the sample when
Right.
it comes in.
Yeah.
And so we want to make sure in the lab that we treat the sample with great care.
Mm-hmm.
And so that we select 200 seeds that are really going to represent that.
Right.
The best way we can do this is through the use of mechanics. So humans present biases, that's just normal, but mechanics more consistently do not. So this is a gamete, and I'll just give it a quick little. And so inside, we have a spinner, and then when you turn it on, see how it just shoots out the side. So that was one pass. And that's 2 passes. And we continue to do that until it's thoroughly mixed.
Right.
Once it's thoroughly mixed, we can then start having our sample so that we're dealing with a much smaller sample. So maybe something like this.
And then that sample is what is going into the lab for the
That's
testing. Okay.
So now we've mixed it. I feel confident that we're going to get an unbiased sample
Right.
from the sample that was submitted to us.
Right.
And then we're going to use this for the rest of the testing.
Okay. Let's see how it goes.
Okay, so let's head into planting and see how we plant this.
Okay.
Here we are again. We are in the planting laboratory right now, and I have with us Joanna Cathcart. Do you want to tell us a little bit about yourself?
So I'm Joanna, and I've been with the company for 16 years now. I started on a farm, and then I worked in agriculture and done agriculture my whole life. So that's kind of how I found my way to the lab. So now I am supervisor of the planting and sample prep department at the lab.
Awesome. Awesome. So Joanna's going to be showing us how we plant in the laboratory today. So we're going to start with sample number 1, which is, this is a sample that was submitted from Northern Alberta. And I know it might sound a little bit odd, but one thing that we want to do here is make some observations. And sometimes I do this by smelling. You know what? When the sample smells like harvest, it's a good sign. So this sample reminds me of a beautiful harvest day. And that makes me feel like there could be some good conditions for this seed.
Right.
So this is a little packet that we had already sub-sampled over planting. And this is what we're going to use for our seed selection.
Okay.
So when we pour the sample out here, we're going to take a quick look at it. And maybe make some observations about its quality even before we start. So what I'm seeing here is some fairly well-formed seeds. It looks pretty good. It smells pretty good. I don't really have any indication that this is going to be a terrible sample by any means, but again, the testing is going to really tell the story. So, Joanna, can you show us how you were going to plant this one?
Sure, I can. So the way that we plant in a lab is as most as possible, we try to use a mechanical means. So what I'm going to use is a vacuum system. So what it does is it sets the seed onto each of these individual holes so that I only have a desired number of seeds for planting. So I'm going to pour my sample out onto my seed head.
Turn the vacuum
I'm going to turn the vacuum on.
Excellent.
So what I'm going to do is I'm going to make sure all of the holes are covered with pure seed. So it's going to be the crop type that's listed on the bag, but it's also going to fall under other parameters of being a whole seed or a seed that is greater than half.
Right.
It can still be insect damaged, shriveled, damaged as long as it's the crop type and greater than half. And I'm going to make sure that I've only got one per hole.
Right. And Joanna,
With the sample.
right. Yeah. Okay.
Right. So what Joanna's doing is she's selecting pure seed. And so there's a definition of pure seed that's given to us according to our accrediting bodies. And we have to adhere to that when we're planting. So our job right now is not to decide which of these seeds are going to grow. We really, what we have to do is understand what the rules are around pure seed and apply them to seed selection. And that's exactly what she's doing. Now, Joanna, I also noticed that you've got this sample here. And it's called control. So what is this sample?
So every day we run control samples with each of our specific testing variables to have a known quality sample. That helps us determine whether or not there's any issues, either with our process, with anything potentially in our paper or water or our germinator situation. So this is a known quality sample that can go through the lab with the sample to help with the other end for analysis.
Right, so it's just another way that we double check our processes in the lab by running these biological. Okay, so while Joanna's finishing up with sample number 1, I'm just going to take a quick look at sample number 2. See what we can learn about sample number 2. Yeah. So again, we have our seed selection that we've already done. And this isn't standard procedure by any means, but I always smell. And this sample doesn't smell as good right off the bat. It just smells a little bit off, and I guess this is just your good smelling. But it doesn't have that fresh smell. So I'm kind of suspicious about this sample. When I pull it out, I'll take a look at it. What I see here is that there is some shriveling on the seed coat. To me, this is a sign that there's been some stressful conditions during pod filling. And in this case, I don't know, it could be maybe something like frost. The other thing that I notice in here is we do have some of those kind of ashen gray kernels, which may be associated with FTK, so freeze-bearing damaged kernels.
Right, yeah.
So right away, I'm kind of curious about really what's happened to the seed in the field, if there's been some environmental conditions that have interrupted that kind of final growth period with the seed and the formation of the seed. So I'm a little bit more suspicious of this one.
Yeah.
And because we have lots of different people working in different locations here, I'm probably not the person who's going to analyze this, or Joanna's not going to be the person who analyzes the germination. So what we'll do is we'll put a remark in this sample in our database, and that allows us to communicate to each other so that when the germination analyst opens up the sample and takes a look in the database, they're going to maybe get a few clues about what we observed when we looked at the raw seed.
Okay. That makes sense.
So Joanna's going to finish the sample, and then we're going to update it into our database.
Right.
And this will start a running ETA.
Right.
So if you are a user of our database, it's going to tell you when you can expect to see the samples. And then from there, we're going to put them in the appropriate germinator, which is super fun. So we'll take a look at those. Alright, so here we are in one of our germination chambers. When we built this building in 2013, we felt that it was really important to put in a unique and efficient germinator system, and we really designed the entire building around these germinators. So these are walk-in germinators. They're capable of maintaining the same temperature throughout the whole place. Every spot on every stack here maintains the same temperature. So this particular one is set for 20 degrees Celsius. This is where we would put cereal crops. And this transmitter sends a temperature update to a software program every 10 minutes.
Holy.
So we always know what's going on in this germinator at all times. If it happens to go above or below our set tolerance, it'll send us an email.
Okay.
Any time of the day.
Nice.
So that's a lucky job. That being said, we really rarely ever have that circumstance. Once a year, we go through this germinator and we take multiple temperatures in multiple locations to make sure that if your sample ends up, let's say, at the bottom over there, or up top over here, or even on this side, they're always going to receive the same temperature. So our samples came in about 4 days ago, and they're ready to get looked at today. So we're going to pull our sample 1 and sample 2 germination samples up. We'll take a look at them and see what they tell us about the seed quality. Awesome, let's go. Okay, let's go. Okay. We're taking our samples out of the germinator, and now we're going to analyze them and see what they tell us about the physiology of the seed. So I'm here right now with germination analyst Moses Palmer. Moses, tell us a little bit about yourself.
So like Carrie said, my name is Moses Palmer. I've been in 2020 labs for the past 2 years. And I recently received my accreditations, so that's exciting.
Yeah.
And
that's about it. Okay, fantastic. So you're going to conduct a germination test on these samples. So do you want to open that first one for us? So what is it that you're looking for in the germination test? How do you analyze this?
so with this, I'm separating normal seedlings, abnormal seedlings, and then any other seedlings, any other seeds that didn't germinate.
Right, so they're going into categories. And so what makes up an abnormal seedling?
Well, with abnormal seedlings, I'm assessing all the essential structures of the seedling. I'm looking at the shoots, I'm looking at the roots, and then I'm deciding whether there is damage to it to the extent that the essential functions of those structures are impaired. So I'm looking at seedlings that will not be able to grow normally under optimal conditions.
Right. So are you able to tell if there's something that's happened out in the field when you look at a germination test?
Yeah. There are telltale signs that we see on the germination test that tells us what the conditions might have been on the field. For instance, when we have frost damage on the field, there's something that we can easily see on the germination test, as well as if there was desiccants applied, weights, or early thoughts when the seed was so fresh. And so we can see that in the germination test as well.
There's a lot you can really tell from just the germination test. So when you look at the sample and you analyze this, what do you think?
So looking at this sample, overall, the germination looks good. If I was to estimate, I would say it would be in the high 80s, say 85. But again, I see signs of fungal growth. So I have pink fungal growth here, and that is a clear sign that there is some fusarium infection, probably on the sample. But then we'll have to get a disease test on it to be able to be sure of what exactly it is.
Right. So it may not necessarily be Fusarium graminearum, which is a totally different ballgame than other Fusarium species.
We'll have to confirm it with a test.
So overall, sample one looks pretty good. Has good potential. There is some disease pressure on the sample. So what we're going to do, because we observed this in the germination test, and we know that this producer has only requested the germination test, but we feel like if they want to use this seed, this is information that's really kind of important to them. So we're going to reach out to them, let them know what we saw, and see if they want to continue with some more testing and do some disease testing and see what else might be wrong with this. Okay, so let's take a look at number 2. So sample number 2, if you remember back to when we were planting it, we thought there could be some disease issues with it. We observed a few FDK kernels, and then we saw some signs of damage that might be consistent with frost. So what do you think about this one?
So you can clearly see that on the test. For the signs of frost damage, we are looking at shriveled seedlings, like seedlings that are growing really slow. We are also looking at damage to the shoots. Usually we have a lot of twisting and a lot of graininess with the shoots. And so in here, you can clearly see some of those. You can see this is clearly frost damaged. These also look frost damaged. And so we see that. And then we also see that there is some disease pressure. You can see fungal growth on different parts of the border. So, yeah.
So there might be some further quality issues with this sample as well. Because there's some frost noted on the sample, I think that it's really important that we look at getting some clear testing done on the sample as well, because frost can really have an impact on the storage life of your seed and on the performance of your seed in the spring as well, in cool, moist, cool conditions. Okay, that is a lot of great information that we're getting from just the germination test. So we're going to call the producer and see what they want to do with the seed.
That's great.
Awesome. We contacted both of the producers for these 2 separate wheat samples, and we come up with a different testing plan for each of them. They both intend to use the seed, but they want to know what their level of risk is if they're going to go ahead and plant this. So if you remember sample number 1, we did see some disease issues in that germination. The germination overall was okay, but it's possible that this germination could do better with maybe some seed treatment. And this individual would like to know what sort of disease issues they're really dealing with. The seed has been produced in an area which does not have a high risk of Fusarium graminearum right now. So it's important to this customer to really know what type of disease is present in this seed. Now, this other one, sample number 2, this was a sample we saw some of FDK, so we are a little bit suspicious about Fusarium graminearum. We also saw on the blotter some evidence that there might be some Fusarium species in here. Okay. So knowing that the sample was produced in an area that already has established Fusarium graminearum, this customer has decided to go with the Fusarium plate test. So the plate test will give a percentage found in the sample. Also, to manage their risk, this farmer is going to to have a Vigor test done.
Yeah.
And that's going to help determine if some of that frost has had a really serious impact on the seed physiology.
Right. Okay. I just had a question. So for this farmer, why are you recommending a molecular fusarium test versus a plated fusarium test for this other farmer?
Right. Yeah. So this farmer also agreed to do a fusarium DNA test.
Right.
And the reason for that is because these are, although they both test for fusarium graminearum, they do supply a different sensitivity of testing. So the DNA test is a bit more sensitive. If there happens to be trace amounts of fusarium, it's going to be picked up in that DNA test.
Right.
What we've seen from the data that we've collected is that the trace amounts of fusarium picked up by this DNA test can actually be an early warning system. Oh, there's maybe some spores in the area. There may be some late season infection.
Right.
So we really want to look at management strategies with fusarium in areas where there typically hasn't been fusarium graminearum established. Right. That DNA test is really the way to go. It gives you the most information.
Right.
So let's go find out how these tests are.
Okay, great.
We've made our way to our molecular diagnostic laboratory, and I'm here with our molecular supervisor, Holly Hamilton. So, Holly, tell us a little bit about yourself.
So, as Carrie said, my name is Holly, and I graduated from the UA in 2018 with a bachelor's degree in biology, and I started working here shortly after. And yeah,
And here we are.
and now it's today.
Excellent. So, Holly's done some DNA testing for fusarium graminearum on our sample number 1. So, Holly, do you want to give a brief explanation of how DNA testing works?
So we do our DNA testing by using the technique of PCR. And that essentially what we do is we start by taking a subsample of seed and extracting any DNA that might be on the seed or a part of the seed. And from there, we can duplicate what we're looking for. So in this case, we're looking for fusarium. So we're going to duplicate it a bunch of times in order to be able to see if it's there. And if it's not there, then we're not going to see any fusarium.
Right. So, will other species of fusarium show up in this test?
Yes and no. If there's other species of fusarium, we will definitely extract the DNA, but we're only looking for graminearum, so that's all we're going to see, and that's all positive.
Okay, so there's no chance that a positive test is going to have any other fusarium other than fusarium graminearum.
Correct.
Correct. Okay. So interesting to know, right? This is very specific to fusarium graminearum. So on this particular sample, we've completed the testing. It just took about a day to get done. What did you find for the results?
So with this particular sample, we found trace results for a low positive.
A low positive.
fusarium.
Okay, so what does a low positive mean?
It could mean a couple of things. It could mean that there's trace results, so it might not be enough to show up again.
Okay.
Basically, there's very little.
Like low levels
Yeah.
in the actual
Mhm.
slot. Yeah.
And that's one of the advantages to this test is it is really sensitive, so we can pick up very low levels of graminearum.
Okay.
It could also mean that there's surface level infection or late season infection.
Okay. Yeah, we've talked about that. Yes.
Mhm.
Right. Okay. Awesome. So what we know now about this sample is that there are some low levels of fusarium graminearum present, and that those levels would be considered to be trace. So that's where the sensitivity in this test is an advantage, especially in those areas where there aren't a lot of fusarium graminearum present.
Yes.
Correct. Okay, thank you very much, Holly.
You're welcome.
We're going to now head to our disease department and find out what we discovered on the plate. Okay, we've just met with our molecular supervisor, Holly, where she's told us that sample number 1 has some trace amounts of fusarium graminearum. If you remember, we also requested a fungal screen on this sample, and we're here to talk to our disease diagnostician, Trevor Moore, and supervisor. So Trevor, tell us a little bit about yourself.
Sure. My name is Trevor Blow. I've been at 2020 Seed Labs for 10 years now. And the lab has changed quite a bit since I've been here. But we're still doing some really good work. Fusarium's changed over the years, but currently it's big concern this year, as it has been in previous years. And it's important to test for it, but also to test for those pathogens that we see in the fungal screen.
Right, and so Trevor, it looks like you've done a fungal screen here. Can you just explain how we do this test? What have we planted the seeds on?
Sure. The medium that we use for fungal screens is potato dextrose agar. It's a broad spectrum fungal growth medium that most fungi like to grow on.
Right, and so what have we tested for on this particular test of fungal screen?
We're looking for any sort of pathogens of concern that may impact the seedling establishment of cereals. And on this sample in particular, we're seeing quite high levels of Fusarium species. They're pretty easy to recognize because they're bigger, white, pink on the bottom colonies. We're also seeing some Cochleobolus sativus, which causes common root rot. Both of these can be certainly a concern if you're using it for seed. They're both controllable with the seed treatment, but you really have to look at the levels to see what it's like.
Right. Mm-hmm. Okay, so it looks like we have some disease pressure on the sample. It's not crazy. The seed might still be usable with the seed treatment. You did mention that you found some Fusarium. Is it Fusarium graminearum?
This is just Fusarium species that are present on here, so we wouldn't report this in a Fusarium graminearum test because we report Fusarium graminearum separately from Fusarium species.
Oh.
Yeah.
Okay. So we know there's trace amounts of Fusarium graminearum from that DNA test, but now we've seen there's a 0%. What does that mean? Is it common to get a result like that?
Yeah, it happens quite regularly. There's several reasons that could happen. One of them is that the Fusarium DNA test looks at more seeds. So if it's less than 0.5% infection, which is the lowest we can do in the Fusarium plate test, then it's more likely to show up on a DNA test rather than a plate test. Another reason is that if you don't have that internal systemic infection in the seed, if it's more of a surface level infection, if the inoculum came into the field outside of the flowering period, if it's on the dust on the surface of the seed, that would show up on the DNA test because we surface sterilize the seeds before we place them on the plate, so that wouldn't show up on the plate test.
Right. Okay, so we're going to contact this grower, let them know what we found. We've really uncovered a lot more about the sample than when we just started. We still have the Vigor test running. It's a relief to see that there is no Fusarium graminearum on here, but there are some trace amounts, so that grower is going to want to consider that when they're making their decision.
Sure.
So let's talk about sample number 2. We did find some FDKs, if you remember, all the way back to planting on this sample. Super curious to see how it turned out.
Yeah, so this sample we did see Fusarium graminearum on.
Okay.
So you can see a few plates here. Most of these colonies are common saprophytes like Alternaria. They show up as these larger green colonies, a little bit of Cladosporium. But the big concern is the Fusarium graminearum colonies, which are quite recognizable on here. The reddish kind of carmine color. Those are Fusarium graminearum, so it's several percentage that we're looking at here.
Okay, and so we've tested obviously more seeds than just these 4
Yes.
What is the overall percentage of Fusarium graminearum present on this sample?
6%.
6%.
Yeah.
Okay, so that's getting a little bit on the high side.
Yes.
We're also going to contact this grower and let him know what we found and see what their thoughts are around the testing. Okay, excellent. Thank you, Trevor. That's some really good information. We're going to go take a look at the Vigor test results and see what more we can discover about these 2 samples based on those results.
Okay, great.
Okay, thank you.
Right, thanks.
Now we're at the final stage of our seed testing, the Vigor test. All of the other tests are completed and we really learned a lot about our seed. Starting from a germination test, we've added on the disease testing and the Vigor testing. It's surprising to see how much more we can really learn about seed quality once we start doing some more comprehensive testing. So let's find out what the Vigor test tells us about this seed.
Okay.
All right, sample number 1 looked okay.
Right.
We planted it, the germination was pretty good. We felt there was a bit of disease pressure in the sample, so we put it through for some more disease testing.
Yep.
And what we found was that there is a little bit of disease pressure in the sample. There are some Fusarium species present, but not Fusarium graminearum. However, we did get that trace Fusarium.
Right.
Now, what the Vigor tells me about this sample, this is our Vigor test, which actually looks really good. We have a really consistent rate of growth. We've had good synchronous germination. So the vigor of this sample is actually quite strong, and I think it's probably even stronger than the germination test itself. So that's great news for this producer if they choose to use this seed. It's quite likely that using some seed treatment, I think they could potentially use this seed and have good success. Let's take a look at our other sample. So this is sample number 2 with those FTKs. We found 6% Fusarium in this sample. And so we're kind of going into it with a high level of risk anyway. Also remember that we found that cross. Consistent to that, the difference, look at the difference in these Vigor tests. So this one is not showing synchronous growth. We've got some seedlings that are starting to germinate much later than other seedlings. You can even see that the disease pressure is so strong that even the low temperature isn't really suppressing that pressure or that the symptoms, I guess, of that disease. So this one right here is probably sitting around 60%. If we combine the okay germination with the 6% Fusarium and the 60% Vigor, we probably have a fairly risky sample to deal with.
Yeah.
This producer might decide that it might make more sense for them to just source new seed that has a higher quality.
Right. Yeah, that makes sense.
Whereas this one, I think that if we treated the seed,
Right.
we might even be able to bring the germination up. So that's exactly what we did. We treated the seed. I found this pink stuff.
That's very nice.
This is actually seed treatment.
Yeah.
And so you can see that the germination has actually increased quite a bit. The dead seeds have not become alive. That's not a thing.
No.
But seedlings which were infected by that disease pressure, which we're showing some abnormal growth here, are now being eradicated by the seed treatment and are able to grow normally.
Right. Nice.
So
That's good news.
Yeah, right?
Yeah.
Good news. So through some management strategies here, I think this producer might decide to actually use this seed. So we started today with 2 samples, very similar, 2 wheat samples with just germination testing. And you can see by taking your seed to the doctor, there's a whole lot more we can learn about seed if we continue testing, and if you use your seed testing professionals to really help you, to consult with you, to help you really understand the true quality of the seed, and whether it's in your best interest to use the seed, or whether you need to maybe change some of your practices with the seed, or to source new seed. So make a good decision. And use your labs, and that's what we're here for. That's what we do. So on behalf of all of us at 2020 Seed Labs, thank you for touring the lab with us today, putting up with some of our noise in the background.
Yeah.
We're a functional working lab. That's what we do. We're always at it. So we appreciate you taking the time to learn a bit more about seed testing today.
Thank you.
Thank you, Rachel and Carrie. That was terrific. We've got a few minutes left, and so I'm just going to remind all of you that if you have a question, please type it into the chat box. Carrie and Rachel, I see you guys were pretty active within the chat itself, so thank you very much for that, and thank you for that great presentation. That was wonderful.
Thanks,
Awesome.
Mark.
Thanks, Mark.
I have a question here regarding Fusarium. What is 2020 Seed Labs recommending for a maximum level of Fusarium in seed?
Yeah, so I can take that question. Oh, sorry, I just cut out there for a second. Yeah, so at the moment, we don't actually have any recommendations for a safe level of fusarium in the industry. There is definitely some collaborations, especially in Alberta, where our lab is located, and also in our Winnipeg lab. In the Prairie provinces, we are collaborating with industry and other fusarium groups to develop a threshold for a safe level of fusarium in the seed. However, fusarium testing is still very, very important to determine your own risk management and how to manage that fusarium level in your seed going forward.
I have a question regarding seed treatment. Does seed treatment aids the vigor of the seed, but not germination, correct?
Right, and so I did try to answer that a little bit in the chat. So in a very specific circumstance, seed treatment can improve your vigor, but that is when the quality issue is due to disease pressure. And so what happens with disease pressure in a germination test is that the seedlings become infected, and then that inhibits their ability to develop quickly or to develop all those essential structures. The application of seed treatment can eradicate some of that disease pressure and then allow for a proper development of those tissues. So under some circumstances, yeah, seed treatment can definitely be a tool to help improve germination.
Can the PCR test be used in the same way for turf grasses to identify disease?
Right, so PCR testing is really diverse, and we've been at PCR testing for a very long time, but there's still so much more opportunities for continued development with PCR testing. Right now, there are, I couldn't even guess actually, but PCR testing is used extensively throughout different crop types for different diseases. So I would say yes, absolutely. PCR testing can be used for disease testing in forages.
I have a question regarding plate results. How can you identify pathogen strains based on plate results? Can you use a more selective method for this?
Right. Our method is really based on the skill of the disease diagnostician. What we do is we grow our seeds on a sterile environment like agar, or I should say in an environment where where it's favorable to grow disease. And then at a certain growth time, we're going to look at the mycelium that's developed. And then based on the morphology of that, we'll be able to identify which species of disease is present.
Do you ever use fusaric acid for screening for fusarium tolerance in seed?
We don't. I'm not overly familiar with that, to be honest, but here in the lab, that's not a practice that we're doing, and I've not heard of that in our region.
And how many seeds do you use to do a disease test on a plate per sample, Carrie?
We test 200 seeds per sample.
Regarding that vacuum seeder you showed, what size hole do you use with the vacuum seeder for small seeds, like say carrots, cilantro, parsley, those sorts of sort of more niche crops?
Right, an excellent question, because I don't really have the answer to that one. You can order them in different sizes. So here in that lab, we have probably 2 or 3 different hole sizes so that we can switch them out for different crop types. The particular one that we would use for small seeded, I can find out that information if the person asking that question wants to email me, but I honestly couldn't say.
How do you conduct a vigor test for wheat? For example, type of stress, temperature, duration?
There are many different vigor tests, and they're selected by labs with the end user in mind. And so what we do here at 2020 is we use something called a direct test. And that's where we're looking at a direct stress on the seed. We're creating that stress in the lab, and then we're measuring the performance of the seed. We are using a cold test method, which is a period of cool temperature. The seeds are in an imbibed state. They're grown at a cool temperature for an extended period. And then at the end of that test period, we take a look at all those seedlings and we apply a minimum growth criteria. Seedlings which don't meet that criteria are considered to be non-vigorous.
Do you find that farmers really push the limits, even with less than ideal test results, to use their own seed as they're worried about bringing in seed from other places, or are they quick to buy certified seed if they have issues?
I think that's a difficult question to answer. I think that both of those scenarios exist for sure. I think it also very much depends on what seed quality has been like that year and where your level of risk is in terms of bringing seed into your farm. Also, seed quality in really years which are poor or high risk, it's maybe a decision to use carryover seed on your own farm versus sourcing new seed. So I would say that both of those scenarios certainly exist, but it's a complex reasoning as to why you would make that decision either way.
When you mentioned the cold test performed well, in your opinion, what is considered good in the cold test?
Right. What we want to see is that our germination and vigor values are quite similar. And I guess if you were taking a math test, you would want to get 100%. Same thing applies here. We always want to see the highest vigor test. Vigor relates to the emergence of your seed. So having a synchronous germination in the springtime is really important to seedling establishment and for your overall quality of your growing crop. So I would say that if your germination result is in the 90s and your vigor result is within 10% of that, I would consider that to be a strong vigor. Once we start seeing great differences between germination and vigor, as an example, let's say that your vigor test is around, or your germination test is around 90, but your vigor test comes in around 60. That is an indication that there's certainly some risk with that sample. And risk comes in several different forms. What vigor test can do is it can predict the life of our seed lot, and seed lots with low vigor results can sometimes be closer to the end of their overall life. So it might be risky to plant something with a very low vigor because we don't know at which point the germination will start to drop off. So always higher is better.
Regarding dormancy, how do you accurately test germination in species that may have dormancy when harvested? I've written about this before, and sometimes we talk about breaking dormancy. Sometimes that's something you guys have to do. Can you offer us a little bit of insight on how dormancy can affect germination testing?
Absolutely. So dormancy is present in many species, and particularly native plant species, because it's a way to ensure the propagation of the species, right? I mean, if all the seeds just fell off the plant as soon as they were ripe, a lot of those plants would start to grow right away, and then they might die because it's winter or the conditions aren't favorable. So dormancy really is a natural protective function of the plant. What we do with cultivated crops is we kind of ask those seeds to maintain some dormancy, but not too much dormancy. There's a fine balance, because when we're ready to plant the seed, we want that seed to start growing. In the lab, it's very common that we apply a dormancy breaker to those crops, and depending on which crop type it is and how deep that dormancy is expected to be, we may apply different types of dormancy breakers. But what that dormancy breaker does is it allows the physiology, the biochemistry of the seed to change, so that some of those hormones which prevent germination and thus give us dormancy can then kind of like balance out and allow the seed to start growing. So really common in a lab that we would do a 3-day dormancy breaker by putting the seed in an imbibed state at low temperature for 3 or 4 days, and then moving it to a warm temperature.
In regards to variability, can you discuss the variability that can be seen across different labs in regards to germination levels? Like, say, one lab has 85% and the same sample receives 90 or above at a different lab. Does that have something to do with abnormals being diagnosed differently by one person versus another, or what do you attribute that to?
It shouldn't. I mean, in the perfect world, we attribute that to math. If the samples are originating from different sampling times, I guess, or events maybe, that in itself creates variability. If, let's say you go out and you sample your seed and you divide it in half, so you're taking a good representative sample, you've taken a number of primary samples from your seed source, you mix them all up in a bucket, you've divided it in half, and you've sent it to lab A and then to lab B. Here in Canada, we have an accreditation standard for germination, and it's our responsibility as labs to perform those tests according to those accredited standards, meaning that we're going to conduct the test in exactly the same way. We also have a standard for training and expertise here in Canada. We have to prove as analysts that we maintain the standard for germination that CFIA requires of us. So we have to take a test and participate in PTs, and there's a whole lot of training that goes into the lab. And then that's really kind of almost simplistic. It almost sounds like it's so much more than that, but what it means is that the same standard is applied, and that expertise is proven, so that you should get relatively the same germination results when you're sending from lab A to lab B with the same seed source. But every time that we introduce a variable in there, we're going to increase the variance that you might see. And I would say the number one way that happens is through different sampling events, different sampling times. Having accurate sampling is one of the most important things we can do. Every decision that we make with seed is going to start with sampling.
Can you clarify what Canada #1 standard means and which test is used to determine if a seed measures up?
I believe that Canada #1, Canada certified #1, if we're talking about seed. This is a pedigreed seed standard that is administered through our whole seed system. It's in a simple way. What it is it's a generation of seed that has a particular standard of quality, and that standard of quality relates to the parents of the seed, the production of those parents. It relates to how the seed is grown. It relates to how the seed is moved, how the seed is stored, how the seed is sampled, how the seed is tested. And once all of those pieces, and there's regulatory bodies that all kind of work together within the system. Once we get to the point at which we have a final test result, then we can apply a certified #1 tag if that's the grade that we're going for. And the certified #1 tag is an assurance of quality. It's Canada's assurance of quality. And once you see that tag, you can know that all of this work and time and expertise has gone into the production of this certified seed, and you can know that you're buying a certain quality of seed.
Regarding endophytes, do you know whether growth of endophytes in seed impacts vigor as seeds age?
What an amazing question that I really don't know the answer to. But I have some friends who might know the answer to that. fortunate enough to be on the ISTA Vigor committee, and there's a lot of beautiful work that's being done by these really highly intelligent people. And I feel like I might be able to find that for you. If you, whoever is asking that question, if you want to email me that question, I'll be more than happy to pass it along and see what else I can find out for you.
And just a reminder, Carrie's email is Carey, C-A-R-E-Y, at 2020seedlabs.ca, right?
CA. Yep, CA.
How do germination tests vary over different countries? What is the most accepted method worldwide?
ISTA, for sure. Germination methods, I would say, vary a little bit from country to country. The basis of them is the same. We're looking for healthy essential structures that are required to produce a normal plant under healthy conditions. I think the concept of germination is the same all around the world, but the standard that's applied can be different depending on the country. So some countries have a domestic seed testing program, like Canada. So we have Canadian methods and procedures that we follow. The US also has their own domestic program. But I think without a doubt, ISTA, so the International Seed Testing Association, is the most highly recognized testing association. The main differences probably come down to the number of seeds which are tested and the finite criteria that's used for determining abnormals. So some testing associations go into a lot more depth about what criteria needs to be applied, whereas other ones may leave the definitions a bit more generalized.
In a specific fungi test, how many seeds do you use?
So I think we're talking about the plate test, which we here, we use 200 seeds, and then we plate them out on 20 plates to get our total percentage.
I'm just going to take a couple more questions here before we sign off for the day. Thanks again, everyone, for spending your lunch hour with us. Can you give us a little forecast what seed quality is looking like this year?
Yeah, we're so pleased in Alberta to have had a good harvest this year. Everybody here who's watching in Alberta knows how much we've struggled over the last few years. We've had some really difficult harvests with early snow and snow on swath and frost damage, and it's been difficult. So this year we had a beautiful harvest, and beautiful harvest can mean good quality seed. All of our, to date, I would say to January, so from September to January, our average germination values for almost all crop types are up in the 90s. Kind of from 90 to 93%, I would say. And we haven't seen any outstanding issues. Now, as I mentioned, with the snow, early snow and snow in the swath that we've seen over the last few years, we've had a lot of frost damage. And I think we spent a lot of time trying to help people understand what frost damage really does to seed quality. But this year, we really don't have any one trending outstanding quality issue. We have some good seed out there this year. We're so happy to get a good year in there and not have to look backwards so much for last year's seed or 3 or 4 years ago just to find something that we think is a better, like more suitable for planting next season. So overall, I would say very good. And just quickly, as we know, Fusarium graminearum has been taken off the Pest Act here in Alberta. It's a significant change in our industry. What we're seeing in the lab here is that the overall Fusarium levels are still fairly low. So when samples are testing positive for Fusarium, they're not a high positive, but we are seeing more samples coming in which do test for some level of Fusarium graminearum. Our latest numbers here are 16% of samples that we're receiving from Alberta do have some level of Fusarium graminearum.
And one final question, how often does 2020 Seed Labs recommend testing seed before planting?
I'll maybe just answer that a bit more generally, but we do recommend 3 times a year. and I guess it depends on your production and your goals and what you're doing with the seed. And it also depends on the seed quality, but absolutely for sure, we're testing at harvest. So that's where we're going to set our benchmark for the seed for the year. So where is our risk? And we want to make sure that we're testing germination, disease, and definitely vigor. If your vigor results in the fall right after harvest are quite low and your germination is high, that we want to test that seed several times through the year to see where our risk is at and make sure the germination hasn't been falling. But in general, I would say that we're recommending that you're testing in the fall. It's a very good idea to test again after cleaning. So there's conditions that can change the state of our seed. So I would test after seeding and then as close to harvest as close to seeding as possible.
Great, thank you, Carrie, and thank you, Rachel, as well for your time today. It was a great webinar. I had a lot of fun, and hope you guys have a great day. And I'm not sure if it's as cold in Alberta as it is here in Manitoba.
It's pretty cold. So, yeah, the polar vortex is moving in.
And thank you to our audience for joining us. Again, this webinar will be made available on our website at germination.ca. If you had a question that you wanted to ask Carrie or Rachel, you can email them, carrie@2020clabs.ca. Carrie is spelled Carey, and Rachel is RACHAEL at 2020clabs.ca. Again, I just want to take one more opportunity to thank 2020 Seed Labs for being today's webinar sponsor. You can check them out at 2020clabs.ca or follow them on Twitter at 2020 Seed Labs. So thank you again, Carrie and Rachel. Thank you to our audience for spending your lunch hour with us. This is Mark Zinkowitz of Germination signing off.
Bye, everyone.
Bye, everyone.